Okay, Team Impact. It's Thursday. We're rolling right along here through the week. This will be the last lesson of the week. We're going to do a digital activity tomorrow. Um, Trying to slow down in this new material here a little bit. So, Sylvia's purchases a soda packaged in a cardboard box shaped like a rectangular prism. In order to recycle the box, she cuts along the edges and flattens dimensional into a two-dimensional surface or shape. Sketch what you think a two-dimensional flattened box might look like. Okay, so what we're going to talk about today is nets. And the net is where you take a three-dimensional object and fold it out flatly to a two-dimensional piece. So let's try this. And I'm not real good at this, but if I look at that soda box, all right, this is going to kind of be the front. Kind of do this with me. And there's a lot of different nets that you can have here. This side and this side is going to kind of be next. But if that's the front, this is the base that it's sitting on, I should say. And then we have this piece and we have this piece, right? So this is the front, the bottom. Okay, here's the back, right? And then this would be the top. So this is the front and the back. Okay, this is the bottom and the top. This would be the right flap and the left flap. So when I look at that, that's kind of what I see. Yeah, you could have certainly took this and put it there and this here because when it folds up. But that's what a net is, taking a three-dimensional object and putting it into a, excuse me, two-dimensional or flat piece. All right, a net is a two-dimensional composite figure. Okay, when folded, a net creates a three-dimensional object. So when it's flat, it looks like this, or this, or this, or this. And then when it's folded up, it'll look like that. Okay. So what we're going to do is identify some things here and find some surface area. Use the nets below to determine which figure would result would result from folding it. Then shade the bases, all right, of the object. Okay. So when I look at this looks like to be squares, and squares are all sides equal. So when we fold this up, this would be a cube, a cube. And when we look at the bases, all right, the bases is what it sits on, and on a cube, it could be really any of these, but that would be a base, and that would be a base. This would be the bottom, this would be the top. Okay. Next one up, this is folded out, and this is kind of what we just did. Excuse me, but this is a rectangular prism. Okay, it's a rectangular prism. And to shade the bases again would be here and would be here. Okay. If we fold that up, it would look like the soda box. Okay. All right, the next one up is a triangular prism. Why? Because our bases are triangles. Okay, that's what a triangular prism is. Okay, now, all right, that means when it's a triangular prism, we have three rectangles. Okay, so this is a triangular prism. All right, we have two congruent bases. So it's a little bit different than this. It's actually not sitting on those. It would be sitting on this piece, but our bases, all right, are separated by a face, as we talked about yesterday. Okay, so next up is now we're going to get into our pyramids. Okay, we're going to go to Egypt here. This is a triangular pyramid. All right, pyramid, Pyramid. Now, a pyramid only has one base, and it's what it's sitting on. So it's a triangular. It's identified by its base. So it's a triangular pyramid. Triangular pyramid has four faces. Okay. A square pyramid would have five faces, and that's what this is a square pyramid. Okay, and this is a base. Okay, so we have a triangular, a square, and now we're to this looks to be like a rectangle. We have a length and a width. You know, the square's all four equal sides. This is actually, if you look at this is an equilateral triangle, some of our vocabulary. So this is a rectangular pyramid. Okay, so some good vocabulary there so far. Looking back, we talked about the nets of our figures of a cube, of a rectangular and of a triangular prism. We folded one out, we got a little vocab, and then we got into our pyramids. Okay, all right, let's flip the page here and see if we can find some surface area of this stuff here. Okay, for 7 through 10, use the measurements from the three-dimensional figures to label the dimensions on the corresponding nets and then answer the questions. Okay. Well, since this is a cube and all sides are equal in a cube, okay, I know that this is 7, this is 7, this is 7, and that's really all I need to know because they're all 7. So sketch a net with 6 squares that would not result in a cube, and that's important to see. So we want one that will not. Okay, so this is a net that will. This would fold up, that up, top, left, all right, bottom, and so on. So one that probably would not, and I'm just going to I'm not real good at sketching. Okay, something like this. Okay, so if we put our 4 across just like they did, but instead of putting a flap down here, if we put one here, and I could add it there, or put one here, that won't fold up to a three-dimensional figure. It won't close the front end. So that does not work as a net. Okay. Number 2. Let's identify what we know here. Okay. So the long edge is 10. This piece is 2, right? And we'll label it at the end. And these pieces here, it looks like, are 6, right? So when we go to find the area of this, we could use these numbers. Give 2 examples of what a nut might be used in real life. Okay, so one is Christmas time, right? If you think about it, all right, this could be, all right, for wrapping paper, right? So how much wrapping paper is needed? So let's just write wrapping paper. All right, and another one could be if we want to paint it, right? The net would help us figure out the area to see how much paint we would need if we wanted to paint this a specific color. Okay, so that's important. Two good concepts there. Next one up, number 9. Rico. Okay, Rico. Oh, I apologize. I guess we should go ahead and label our numbers here. All right, so let's be careful here. We got a long edge here, 15. All right, we have the height of the triangle, which is 6, and we got to find that perpendicular. So I'm just going to kind of draw that and write a 6. And then see the slanted height? This slanted height of the triangle, which is actually the edge of the rectangle when it folds up, is 6.5. Okay, and with those dimensions, we could find the surface area because this is an equilateral triangle. All sides are equal. Rico was asked to shade the bases on the net, and he shades the rectangles. Explain why the rectangles are not the bases in this. So this is, a triangular prism, okay? And the reason we wouldn't shade the rectangles is because the bases must be opposite and parallel to each other. So this is opposite of this, and they're parallel. When it folds up, they will never touch. They will never intersect, all right? If you look at it this way, there and there. This triangle and this triangle will never intersect. So the triangles represent the bases of the prism, okay? So if you think of it that way, all right? The bases must be opposite. Opposite and parallel. Okay? Just a quick note there. Yeah. All right. Number or letter A. Okay, we got a, excuse me, it looks like to be a rectangular pyramid because I have two different dimensions here. So this is 8 and this is 12. Okay, now we have to be very careful. Okay, on the 8 side, which is this side and this side, so this is actually 8, the height of the triangle is 9, is 9. But on the 12 side, and that's 12 there because opposite sides of a rectangle are equal, this is actually 8. Okay, and it's giving me those dimensions right there. Okay, there's one more piece here, it looks like. The slanted height right here, this slanted height, okay, I'm on the 12 with the 8. This slanted height or this slanted height is actually 10. And that's all in feet, and I'll label that later. All right. Delio says that a pyramid is unique because it has one base. Do you agree or disagree? Well, I certainly agree. All right. The base identifies it. So we can have a rectangular pyramid, a square pyramid, or a triangular pyramid. All right. So that I agree. Pyramids, excuse me, have one base. Okay. One base. So some more good vocabulary here. And as we look at this, if we flip this page over, okay, you're going to be actually doing this intro to the nets. Okay. So, all right. And then on actually Monday, we're going to be taking a look at this. But intro to nets, do numbers 1, 2, and 3. It's true and false. And then you need to rewrite these statements. Okay. So make sure you do a good job. There's not a lot there. All right, guys, have a good day. Take care.